In this video, we'll show how quadratic functions in vertex form are related to a basic graph of y equals x squared. So in this example, we're asked how do each of the following functions compare to the graph of y equal x squared? And what we're getting at here is how are they shifted? If we take x squared, what would we have to do to x squared in terms of shifting it left, right, up and down, etc., to get it to look like these functions. So the first function is g of x equal to x minus 6 quantity squared minus 4. And we want to know how is that shifted. It's got some horizontal and some vertical shifting. So let's go to Desmos here and look, just explore this for a minute. So I want to just start with y equal x squared because that's what we're supposed to compare everything to, and I just want to get a sense of this just generally, not just for the examples that we were given in the problem here, but to just look at this. So first of all, x squared. Hopefully we're already familiar with what y equal x squared looks like. Its vertex goes through the origin, it opens up. Now, in this problem we're asked to look at horizontal and vertical shifting. Just for fun, I want to look at the what happens if we make this negative right out front. What happens when we change up the leading coefficient? So if we make x squared negative, then all of the y values change sign, right? And it has the effect of reflecting it in the x-axis. So now we have a parabola that opens down. And in general, Desmos is great. You can add a little slider. So if I just put in a generic a value there, so it has a equal 1. If I make a larger, you see it multiplies all those y values by whatever a is, right? So if it's a bigger value than 1, all the y values are going to get much bigger, much faster. Whereas if it's between 0 and 1, it's going to get wider, and if it's negative, it's going to open down, right? And okay, so that's kind of fun to look at. Okay, so now more the task at hand here. We were asked to look at what happens. In fact, I'm going to graph something entirely different here. Y equal x minus 6 quantity squared, right? Now, we had a minus 4 in there on the function, but I just want to pay attention to what happened here. So I kept x squared where it was, right? And I graphed x minus 6 quantity squared. And really, that is exactly the same graph shifted to the right 6 units. Right? You think if we were subtracting 6, it would go to the left, but no, it goes to the right, 6 units. And you can think about that in terms of, well, what would I have to put in for x there to make the y value 0, right? Because thinking about that vertex, it's right along the x-axis, right? So if the y value is still 0, x would have to be positive 6 in there, right? 6 minus 6 is 0. So I always think about it that way. Now, similarly, we'd have to have a negative 6 in there for x if we added it, right? So if we have x plus 6 quantity squared, it goes the other way. All right, so we got a sense of that. If we're adding a value, it goes to the left. If we're subtracting a value, it goes to the right. And we can even put in a little slider here, right? I'm going to have x minus a to kind of show that. Right, so if a is positive here, we have x minus a inside the parentheses. It goes over to the right. If a is negative, then we're subtracting a negative. We're really adding, and it goes over here to the left. Okay, so what happens inside the parentheses is a horizontal shift. It affects what's happening to the x-coordinate, but the y-coordinates don't change at all. Now, I'm going to get rid of that for a second. Let's play around with this a little bit more. What if I just have plain old x squared and I subtract 4 from it? What happened? The whole thing shifted down 4 units, right? What if I add 4? Up it goes, right? So the vertical shift goes the way you think it's going to go. If you're adding, it's going to go up. If you're subtracting, it's going to go down. But it's a vertical shift when you're adding or subtracting a constant, what we would call outside a function. And we could take a look at that more generally, right? So if we had x squared plus a, and we just shift a, right? It's going to take that function and shift it up and down depending on whether a is positive or negative. Okay. All right, so let's look at the one that we have now. I'm just going to leave x squared graph there, and let's graph x minus 6 quantity squared minus 4. Okay, so that's a graph that's been shifted over 6 units to the right and down 4, right? And so that's what we want to say about what's happened to x squared here. It's shifted to the right 6 units and down 4 units. Okay, so we're combining the transformations at this point. And yes, we could even put 2 sliders in here if we wanted to, right? So yeah, this one will affect the horizontal and this one will affect the vertical coordinates, right? So when we have this function g of x is equal to x minus 6 squared minus 4, that's taking the graph of x squared and shifting it right 6 units and down 4 units. Okay, so in the next example of h of x equal to x plus 2 quantity squared plus 5, remember what we were just talking about. If you're adding inside the parentheses x plus 2, it's actually shifting it to the left. So this one's going to go to the left 2 units and up 5 units, right? Okay, so that's the main message. If you're adding or subtracting a value inside the parentheses, it shifts it right or left. If you're subtracting it, it's going to shift to the right. If you're adding it, it's going to shift to the left. The vertical shift is on the outside of the function. So outside the parentheses, if you're subtracting, it shifts down. If you're adding, it shifts up.